Hello, welcome to today's video. Today we're going to be looking at averages. So first of all, what are averages and what do we use them for? Averages are used where we have a lot of data about something. It is too slow or difficult to look at each item of information one by one, so we use an average. Averages are also used a lot to compare things. For example, let's compare the average age of students in your class with students in another class. Let's say that in your class there are 25 students and their ages are between 18 and 23. In the other class there are 21 students and their ages are between 19 and 21. To look at all the data about every student's age in both classes would take a long time, and it would be hard to explain the results to other people. With an average, we are saying, this is the typical or normal age for a student in my class. So how do we make averages? To calculate the average, you add all the information together and then divide by the number of pieces of information you have added. So it's a fraction, if you like. On the top is add all the numbers. On the bottom is divide by how many numbers you added. So if in your example your numbers are 5, 7, and 9, so you add together 5, 7, and 9, which comes to 21, and that's your number on the top. And then for the bottom, how many did we add? So we added 3, number 5, number 7, and number 9. So we have a calculation 21 divided by 3, which of course equals 7. So the average is 7. In the example before, the classes were not the same size. If we didn't have averages, that could be a problem. For example, if we added all the ages in the class, it would always show that the class with 25 students was older than the class with 21 students because they have more numbers. Because the last step in making an average is dividing by how many numbers you've added, the different class sizes are not a problem. So imagine we want to compare the number of cases of malaria in China and Thailand. Which country do you think has the most? The answer is China, because China has many, many more people than Thailand. Let's say I want to go from Myanmar to study in Thailand or China. I haven't decided yet, but I'm scared about getting a malaria. Which country is the most dangerous for malaria? We know that many, many more people in China have malaria. So can we decide that China is more dangerous? And the answer is no. It could be that in China, 1 out of every 500 people gets malaria, but in Thailand, 1 out of every 300 gets malaria. And that means Thailand is more dangerous. So only counting the number of people with malaria doesn't give the right answer. Averages are the answer to this situation. If you count all the people who get malaria and divide by the total number of people, you can find that on average, 1 out of 300 get malaria in Thailand and 1 out of 500 in China. So to summarize, averages are very useful for comparing numbers from different groups or situations, especially when the groups are not the same size. Averages are not perfect. Every time we use a way of presenting figures in a way that is quick and easy to understand for the reader, we have to leave out some information. If we didn't, it would still be long and hard to understand. So let's go back to China versus Thailand. Malaria situation. What if the death rate from malaria in Thailand was 4% and the death rate in China was 10%? Would you still feel safer studying in China? What has happened here is that when we try to simplify the data and make it easier to understand by making an average, we lost the ability to describe how deadly the disease was in the two countries. Averages can also be moved a lot by who you include in the group and who you leave out. For example, if we calculated the average age for your class, it would be near to 21. If we then included the teacher, what would happen to the average? It would go up quite a lot, especially if the number of students in the class is small or if your teacher is very old. So, summary, when the average reduces the description of the group to a number, the reader loses any sense about subgroups or detail within the group. We can show this by looking at two averages that are the same. So class 1 has 3 students. Their exam scores are 50%, 51%, and 49%. If we add these together, 50 plus 51 plus 49 equals 150. Then we divide by 3 because we added 3 numbers together. So 150 divided by 3 equals 50% average. Class 2 also has 3 students. Their exam scores are 0, 100%, and 50%. If we add these together, 0 plus 100 plus 50, we get 150. And then we divide by 3 because we added together 3 figures. So 150 divided by 3 equals 50%. So the two averages are the same, but the underlying data is very different. The first one, they were all very close to 50. In the second one, they were a long way away from 50. Another difficulty with averages is that the answer may be something completely unnatural. For example, let's say the number of babies born in Titale is like this: 2020, 15. 2021, 13. 2022, 18. 2023, 20. 2024, 15. So the average for the 5 years is 15 plus 13 plus 18 plus 20 plus 15, which equals 81. And we divide by 5 because we have 5 different years numbers that we've added in. So 81 divided by 5 equals 16.2 per year. But what is 0.2 of a baby? There's no such thing. And no one in Titale has 0.2 of a baby. So now we have some quick questions for you. For each question, you have to say what the number you divide by to get the average will be. You don't need to find the average, just what the number on the bottom that you divide by will be. So question 1, you have 1, 5, 9. Question 2, 5, 4, 16, 3, 18. Question 3, 16, 91, 56, 43, 66, 21. Question 4, 1, 2, 99, 100, 11, 88, 54, 45. And question 5, 17, 20. So I'm going to give you a moment, but not long, because I'm going to go ahead with the answers now. So pause the video if you need to. And the answers are, for the first one, 3, because we had 3 numbers, 1, 5, and 9. Question 2, 5, because we had 5 numbers, 5, 4, 16, 3, and 18. Question 3, 6, we had 16, 91, 56, 43, 66, and 21. Question 4, 8. I'm not going to read all those ones. And question 5, 2. Okay, so in each case, when you're doing the average, those will be the numbers that go on the bottom. Now we're going to look at reverse averages. Reverse means backwards, so it's like backwards averages. The average calculations that we've looked at so far are like this. On the top, we have add all the numbers. On the bottom, we have the number of numbers we added, and the answer is the average. Sometimes a question will tell you the average and ask you to calculate one of the other figures in the formula. So they might give you the average and how many numbers you added and ask you to calculate the total of all the numbers. Or they might give you the average and the total of all the numbers and ask you how many numbers were added up. Here's an example. The average speed of the cars on the main highway was 80 kilometers per hour. The total speed of all the cars together was 640 kilometers per hour. How many cars were there? So they've given you the average and they've given you the total of the speed of all the cars added together. What you have to figure out is the number on the bottom. How many cars were there? Okay, so back to the original formula. Add all the numbers, divide it by how many numbers you added, and that gives you the average. The reverse average question asks us for the bottom figure. How many we added? How many cars? To get the formula, we have to multiply both sides of the equation by how many and divide by the average. So it becomes add all the numbers divided by the average, and that will tell us how many cars in this case. Now we can use this formula to solve the question. The question was, the average speed of the cars on the main highway is 80 kilometers per hour. The total speed of all the cars together was 640 kilometers. How many cars were there? So putting these numbers into the formula, we get 640 divided by 80, and we work that out. You can cross out both the zeros. Then it's 64 divided by 8, and the answer is 8 cars. Now we're going to look at recalculating averages. This is a situation that happens a lot in real life. You've already calculated the average when some new information arrives. So for example, there are 25 students in your class. On the day of the exam, 2 students were absent. You mark the papers for the 23 students who did it, and you calculate the average, and it is 60%. Then the 2 absent students come back to school and sit the exam. How do we change the average to include the last 2 students? Let's say they got 65% and 61% in their exam. So let's start with the formula. Add all the numbers on the top, on the bottom, how many numbers you added, and that'll give you the average. Now the teacher knew all these figures when she calculated the first 60% average, but the question doesn't tell you all of them. So we can put the numbers we know into the formula as follows. Add all the numbers? No, we don't know that number. How many numbers you added? Yeah, we know that was 23. And the average? Yes, we know that was 60. So there it is. You can see in red the ones that we already know. So you can move this around and get the add all the numbers will equal 60 times 23. So you basically, we're going to multiply both sides by 23. we multiply the left-hand side by 23, which is just the same as cancelling the division on the bottom. And then we have to multiply the right side by 23, so we get on the right 60 times 23. So the add all numbers number must be 23 times 60, which is 1380. So now we have all the bits of the original data. We have to add in the two new exam results. So it becomes on the top 1380 plus the two scores for the two late students, 65 and 61. On the bottom, we used to have 23. We've got two more, so we have to add them in, and then we can calculate our average. So we do all those additions, and we end up with 1506 on the top and 25 on the bottom. When you do that calculation, it comes to 60.24. So that's our new average, including the two late people. Okay, we've looked at three kinds of average calculation. So next is a quiz. In the quiz, you don't have to find the average. You just have to write the answer. Is it a simple average, or a reverse average, or a recalculated average question? So here's the question. Thrapuedo's ducks laid eggs like this. Monday, 5 eggs. Tuesday, 3. Wednesday, 4. Thursday, 7. Friday, 2. Saturday, 5. Sunday, 2. What is the average per day? So you don't have to answer that question. You just have to say which kind of calculation is this, a simple, a recalculation, or a reverse. And I'm going to tell you the answer right now. And the answer is it's a simple one. Okay, next question. Later on Sunday, Thrapuedo found 3 more eggs. What is the new average? Again, you don't have to calculate the average. Which kind of question is it? And I'm going to tell you the answer now. It's a recalculation, because you already calculated the average, then they found some more eggs. Next one. The guards checked the average weight for trucks crossing the bridge from Mesotomiaudi. It was 1 hour and 10 minutes. The total amount of time all the trucks they checked waited was 9 hours and 30 minutes. How many trucks did they check? Again, you don't have to do the calculation. Just pick which kind of calculation it is. And the answer for that one is reverse. Okay, let's move on. Next one, how many do I need to get this average? This one is similar to reverse averages, but instead of having extra information, we're trying to work out what the extra information needs to be to get the result that we want. So let's look at an example. It might make it a little bit easier to understand. So to pass grade 10, you need to get an average of 50% over 5 subjects. The subjects are English, Karen history, math, geography, and science. You've already finished your exam for everything except science, and your results were 60% for English, 55 for Karen history, 40 for math, and 45 for geography. What score do you need to get in science to pass the whole of grade 10? Okay, you need 50% to pass grade 10. So it is saying, what score do you need to get in science to get a 50% average? And I'm going to go on now. So this time we need to find out what the add all number figure needs to be. We know that the average needs to be 50, and we know that there are a total of 5 subjects. So we can write it like this. Question mark, what does the total score for the 5 subjects need to be? On the bottom we have 5 for the 5 subjects, and on the right equals 50% pass mark. So to find the total marks we need for all the subjects together, we have to multiply both sides by 5. So we need to get rid of the 5 on the bottom. On the left, if we multiply by 5, that is gone. And on the right-hand side, we will have 50 times 5. So there it is, question mark, the number that we're looking for, equals 50% times 5. So then the question mark equals 250. So we can say the final formula has to look like this. We add all the numbers and they will come to 250. There are 5 subjects on the bottom, and out of that, the average will be 50%. So we can say we need a total of 250 marks for all subjects together. Okay, the last step is to calculate how many marks we've already got. So for the subjects we've already finished, we got 60 and 55 and 40 and 45, which add up to 200. So we already got 200, and we need to get 250. So for science, we need to get 250 minus 200. We need to get 50% to get our overall 50% average for grade 10. Okay, what if you want to add averages together? What if we have 2 averages we want to join together to make 1 average? So let's say there are 2 grade 10 maths groups. One group is 20 students and the other is 25. The average exam mark for the 20 group is 60%, and the average for the group of 25 is 50%. Now the important thing, and it's very important, that you have to get into your brain here is that you can't just add 50 plus 60 and divide by 2, like the way you normally find an average. You can't do that because they are already averages. So, big lines through that. So, what is the right way? The key is to remember that we are looking at the records for 45 students. The average for 20 of them was 60, and this is the same as saying 20 of them all got 60%, and the other 25 got 50%. So this is like saying they all got 50%. So it's like you're asked to calculate the average of this list of scores, and you've got all the 60s there and then all the 50s. So you've got the records for 45 students there. You can add them all if you want, but it's very slow. It's much quicker to multiply the 60s by 20, the number of students who got 60, which comes to 1,200, and then the 50s by 25, which is the number of students in the second class, and that comes to 1,250. Then we add those two together. 1,200 plus 1,250 equals 2,450. And then we divide by the total number of students, which is 45. So 2,450 divided by 45 equals 54.45%. And that is the combined average for all of grade 10. Last thing, do a quick reality check. It's always good to check that your answer is roughly where you think it should be. So we have 2 groups here, similar size. One group got 60% and the other group got 50%. So the average should be roughly halfway between 50 and 60. In other words, 55. And yes, our answer was 54.45. So yes, it's close to 55. So it passed the reality check. And this is the end, my friend. See you next time.